Come on in, and this time we're going to be looking at solving inequalities. And we have x minus 3 is less than 2, or in other words 2 is greater than x minus 3. Great. And we're trying to solve for the value or possible values of x. So how are we going to get this done? The good news is, if you know how to solve equations already, guess what? You're halfway there. So we want x to be by itself, so we need to get rid of this minus 3 that's here. So we think about what's the opposite of minus 3. The opposite of minus 3 is adding 3. So we're going to be doing that on both sides of the inequality, just like a normal equation. So I'm going to add 3 to this side, and I'm going to add 3 to this side as well. What that does, minus 3 plus 3 cancels down to 0. So whoops. So we're going to have x on the left side, and we're going to keep this sign right here. Good. So now we have 2 plus 3, and that works up to be 5. So x is actually less than 5, or in other words, 5 is greater than x. Easy, not true? Let's look at another example. This is example number 1, and we're going to look at example number 2. That will be x plus 4 is going to be greater than or equal to 5. Good. So we need x to be by itself, so we need to get rid of this plus 4. What's the opposite of adding 4? Subtracting 4. So we need to do that to both sides. Minus 4 on the left and minus 4 on the right. And we're going to work that down now. So positive 4 along with a minus 4 like this, it cancels down to 0. So x is left on the left hand side by itself. And we are going to keep this sign. And now we're going to work out 5 minus 4. And that's just 1. So x is going to be greater than or equal to 1. And when you think about it, what are some possible values of x? What are some numbers that are greater than or equal to 1? You can have 1, 2, 3, and go on. Let's look at another example. That would be what we call the solution set. Values of x that satisfy the inequality. Let's look at another one. We're going to have minus 2x is greater than 3. Now this is where I need you to pay attention. Good. Notice that there's a minus coefficient on that x. That is where things are going to get a little, messy. So to get rid of this minus 2, we need to divide both sides by negative 2. With me so far? But the problem is, in inequalities, when you're dividing or multiplying by a negative number, you're going to have to switch the inequality sign. And there's a good reason. Let's check this out. So when we divide by negative 2 on both sides, these will cancel, leaving us with just x. And when you divide 3 by negative 2, you're just going to get negative 1.5. Good. Remember I was saying, when you're dividing by a negative number, you have to switch the inequality sign. So the opposite of greater than in this case would be less than. Right. Good. So we need values that are less than negative 1.5. That could be like negative 2, negative 3, and so on and so forth. Let's look at another example. Number 4. It's going to be x over negative 5 is less than or equal to 2. You see the problem? This is the problem. This divide by negative 5. So whenever we're multiplying or dividing by a negative number, we need to change the inequality sign. So to get rid of this divide by negative 5, we need to multiply both sides by negative 5. Multiply by negative 5. And keep in mind that when we are multiplying or dividing by negative, the inequality sign would switch. So instead of less than or equal to, we're going to have greater than or equal to this time. So this multiply by negative a half cancels that divide by negative a half. So we have x on the left hand side. Notice that we need to multiply this 2 by this negative 5. And we're going to get negative 10. Easy, don't it? Let me throw on one more. So this is going to be example number 5. And I'm going to make it as hard as possible. I'm just joking. It's going to be negative 4x minus 5 is going to be less than 15. Good. So first we need to get rid of this negative 5. And what we're going to do is to add 5 to both sides. Whoops. Add 5 to both sides. Great. So this negative and positive 5 together will cancel, leaving us with this minus 4x on the left. Keeping the sign. And 15 plus 5 is 20. Look at the drama now. Notice that attached to the x, we have this negative 4. So when you see that, you don't know, so the inequality sign has to flip to the opposite. So instead of less than, we're going to have greater than. And then we'll just go ahead now and divide both sides by negative 4. These will cancel, leaving us with just x. And negative 4 into 20 goes negative 5 times. Great. And that's it. That's all there is to it. So, why is it that we flip the sign when we're dividing or multiplying by a negative? Let me just show you. So here I have minus 2x is less than 6. We're going to solve for x. Simply put, we just divide both sides by that negative 2. So, when we cancel this down, whoops, we're going to have x is supposed to be less than, and you work this out, you get negative 3. No, it's saying that x is supposed to be less than negative 3. A value, I'm going to pick the next value right after that, which is less than negative 3, which would be negative 4. So we're going to substitute negative 4 into the inequality and see how it works. So the value less than negative 3 is negative 4. So we're going to have minus 2 minus 4 is supposed to be less than 6. Great. So we're going to work this out. Negative times negative gives us a positive. And 2 times 4 will give us 8. And is 8 less than 6? Not exactly. To make this correct, we have to say 8 is greater than 6. We have to flip the sign. So this is why when we divide by a negative or multiply by a negative, we have to switch the sign in order for the results to make sense. Got you?